In this video, we will learn about the MATLAB interface for Databricks. MATLAB and Simulink enable the design, development, and operation of a wide range of engineered systems across many industries. Databricks is a cloud-based data platform that helps businesses analyze, manipulate, and study data. It provides best-in-class capability for creating and scaling Spark-based workloads for data engineering, machine learning, and collaborative data science. Starting in 2020, the MathWorks began offering a support package called the MATLAB Interface for Databricks to help engineers connect with, understand, and manipulate data in the Databricks platform. In addition to helping engineers do their best work, this support package helps foster collaboration among people in differing roles through a shared focus on the data. In today's overview, we will learn how the MATLAB Interface for Databricks can help you leverage the strengths of both platforms to accelerate your work and unlock new or additional value from the data. The MATLAB interface for Databricks enables three important data workflows, and it can be helpful to think about these workflows in the context of an XY relationship. On the y-axis, let's consider three related ideas: data size, risk sensitivity, and business value, on a scale from low to high. On the x-axis, we describe the notion of software maturity and data access style on a scale that starts with development and looks toward production. With this framework in mind, we can start to place and relate the different workflows supported by this interface. The first data workflow helps you develop quick insights and supports interactive prototype work. The second data workflow is about directly using Spark to work with and manipulate data. And the third workflow helps us take known good MATLAB code or Simulink models and expose them for use in different compute contexts in Databricks. It's important to note these workflows do not have to exist in isolation. They often overlap and inform each other. Next, let's learn a little bit more about each of the workflows. Our first data workflow is interactive, exploratory, and tends to be highly iterative by its nature. This type of work generally requires smaller datasets to develop and test out ideas. Engineers connect to and explore data in Databricks, all from their local machine. This is done by means of the MATLAB database toolbox and SQL semantics. There is no explicit use of Spark here. Fundamentally, this workflow helps us wrestle with the idea of the data I need to use is in Databricks. Now what? The second data workflow is about directly using Spark to work with and manipulate data. Much like our first workflow, this one can be interactive, exploratory, and highly iterative. It enables engineers to author Spark commands from MATLAB on their local machine and have them executed in Spark on the Databricks compute. Data reading, manipulation, and writing all happen on the cluster side. This data workflow opens up access to larger data volumes and helps us progress the maturity of our algorithms or models from development toward production. The final data workflow in the support package helps us take known good MATLAB code or Simulink models and expose them for use in different compute contexts on Databricks. So far, we've seen how the first two workflows help us develop insights and tackle data at varying scale. This production-focused workflow helps us move our MATLAB or Simulink to the data. This is done by using the MATLAB or Simulink compiler family of toolboxes. Code or models deployed in this way are called as part of Spark jobs running on Databricks. This workflow is best suited for stable models and code, along with large volumes of data, like we typically see in production. The MATLAB interface for Databricks was designed to meet you where you are along your data journey and help get you where you need to go. We saw and discussed three workflows. The first one talked about developing quick insights and interactive prototype work. The second addressed the direct use of Spark from the MATLAB desktop and execution of those commands on the Databricks cluster. And the third workflow helps us with the idea of taking known good MATLAB code or Simulink models and using them in a production context on Databricks. Installation and setup of the MATLAB interface for Databricks support package requires coordination between you and your IT colleagues. We're connecting your desktop software with a cloud solution that needs to keep your business data safe. MATLAB has 2 releases a year and monthly updates. Databricks, a cloud software company committed to your data security, updates far more frequently. One potential challenge is keeping both sides in sync without compromising engineering or security. And this requires focused coordination and communication between engineering and IT teams. We can help with these discussions. Get started today with a three-phased approach. Phase 1, go to mathworks.com and download the MATLAB interface for Databricks. Phase 2, think about the workflows we discussed here today and how they relate to the work you do today or the work you want to do in the future. And Phase 3, after successfully piloting one or more of the workflows in Phase 2, consider how you will roll these out to your team. Whether you need support for the IT setup, engineering adoption, or operational support, we're here to help. Please contact us with questions about installation or workflow adoption. Thank you for joining us today to learn about the MATLAB interface for Databricks.